Okay, I'm Chris Nelson, and welcome to Beyond Request Response, why and how we should change the way we build web applications. A little bit of introduction. I am a 25 plus year web app developer, which means I have been building web applications since that existed, which is kind of cool and fun. And I'll try to bring some of that perspective to this talk. Sorry about the feedback. I'm also co-founder of a custom software development company called Launch Scout out of Cincinnati, Ohio. I am also the creator of LiveState, which is a set of libraries that implement the ideas that I'll be talking about today. It's not the only one, though, and the ideas are really more important than the implementation. So basically, the impetus for this talk is really kind of an observation that I hope isn't unique to me, and that is mainstream web application development compared to how we did things 5 to 10 years ago is considerably more complicated, generally slower to build the same amount of functionality. I realize this is highly opinionated, but less enjoyable, at least for most devs I talk to, and not noticeably better. So that's kind of the premise of this talk, and really it's about kind of what happened, how we got to this spot, why it happened, some thoughts about that, and then hopefully a good bit of time talking about some ideas that we can use to make things better. So I will jump right in. It's also kind of a design pattern talk. The kind of focus that I'm going to be talking about as far as like ideas for solutions is really kind of centered around a design pattern. So with design patterns, we'll talk definitely implementation, but it's really the idea and the pattern that's more important. So if you see some of my implementation choices and you're like, I don't like that, we should do it this way, please try to think about the ideas more than nits with the specific implementations. All right. So let's do some fun history. Let's go back in our time machine over the course of the history of web application development. And I'm going to kind of try to break things into 3 little time periods that I kind of chose arbitrarily. But I'm going to start with the dawn of time. Was anybody developing web applications at the dawn of time? Oh, yeah, a few old folks. Awesome. I love it so much. So yeah, back in the dawn of time, we had fun browsers like Mosaic or Lynx, and then eventually Netscape kind of came along. And at the very beginning of web applications, there was no dynamic anything. And the way we built web applications during this time was typically something called CGI, or the Common Gateway Interface. And in a lot of ways, it was the web app equivalent of stone tablets, very primitive. It was extremely simple. Basically, you had programs that your web server talked to, where the web server just handed the whole request to the external program, and that program returned some HTML to send back. And that's it. So these programs could be written in darn near anything. Perl was very, very popular. But there are also like terrible ideas, like writing these in Visual Basic or using PL/SQL stored procedures that output HTML. All kinds of flowers grew, so to speak, and lots of them were terrible. So in general, this approach worked okay for tiny things. It worked really well for tiny things. Just handling a form and doing something simple with it was great. But when you really tried to build large applications, it got out of control really, really quickly. And we really had no concept of like, how do we organize this code and keep things under control? So yeah, you got spaghetti nightmares pretty fast. So next period of time, I'm going to sort of bucket as 97 to 2005-ish. And the interesting thing that happens at the beginning of this is Netscape introduces Java and JavaScript at pretty much the exact same time, back in 95, I think. So a little before this. But at the beginning of this time period, Netscape completely owns the browser space, like virtually 100% share of the market. Meanwhile, Microsoft, Windows is going strong, of course, and they're observing this thing that they don't control taking over the internet. And they kind of got pretty nervous, like in a lot of ways, understandably so. And so they had their own browser, Internet Explorer, which when they first came up with it was pretty much used by no one. But they worked on it, they evolved it, they made it better and better, and they also did something else, which is that they bundled it into Windows so that it was the default browser for everyone that used Windows. And basically what happened is as soon as it got good enough, which probably happened like IE4 or so, people just started using it all the time, and eventually it completely won the browser war. And it got to about 95% market share by 2004, which meant you could just develop for IE and not pay attention to anything else, and that's pretty much what everybody did. The other thing that happened during this time period that's of interest to us is we finally found some interesting patterns for how we organize our code. And the main one we used was server-side model view controller. It gave us finally some decent code organization. We had a place for the state for our application, and that was on the server, typically in the database. And as these server-side MVC patterns and frameworks improved, we really did get to the point where we could build web apps quite quickly and quite fast. With kind of the big caveat, which was okay at the time, that mostly we just ignored JavaScript. It was mostly just an afterthought to add some like little dynamic bits, but we really didn't care about it very much. And then something interesting happened. About 2005 to 2015 is when Ajax kind of came on the scene and got more and more important. And kind of the first example of Ajax and dynamic apps that did things in the page without a page reload. The kind of first one that was really mainstream was probably Gmail. Google Maps was around this time period as well. And it really kind of set a whole new bar for us as web application developers. It kind of established a new standard for us to live up to. The other thing that happens, by this point, IE is completely won. And really, we don't have a lot of innovation happening in the browser because IE doesn't really need to, so they're not really putting a lot of effort in. And standards are not really that big of a deal. So over on developer land, what kind of happened to us, the user experience of using these apps is a lot better, but the developer experience is kind of a lot worse. Things on the client really get pretty complicated, and we're kind of left with trying to figure out how do we manage this client-side complexity. And this starts what I kind of like to refer to as the client-side MVC cycle. And it starts with a pretty understandable, decent-sounding idea, which is let's apply those same good ideas that work to organize our code on the server side to the client side. I know, we will build a JavaScript MVC framework. Great! And then over time, what happens is they just get more and more complicated. And when somebody new comes on the scene, they're like, oh man, that MVC framework looks super complicated and hard to figure out. I know, I'm going to build a really simple, easy to understand MVC framework. And then that one gets complicated and it just kind of like loops. And that's kind of what happens for years and years and years. And my basic, hypothesis there is what actually is happening is that these MVC frameworks are solving a problem, but not the main problem. And the main problem that is making these web applications so complicated is that we have our state in two places. We have two MVC frameworks managing state, and we're ad hoc sending messages back and forth to keep that state in sync. And that's the actual complexity that is making things more difficult for us. And guess what? This means we are now doing distributed application development, and that's not an easy problem to solve. HTTP, as we all know, is a stateless thing, but to have our applications be usable, of course, they really do have state. And when we were doing just server-side MVC, we had like a single place for our state, and that's why we could go so fast when we were building apps. But now we have state in at least two places. We have to keep it in sync. Shared state's hard to manage. Shared mutable state is almost impossible to manage. If you don't believe me, does anybody remember Corba? Corba, shout out for Corba. Yeah. Okay. That's enough of that. And we have to manage all this client-side code, right? We have client-side build tools and dependency management and compilation and transpilation. We just got a lot to deal with. So now let's kind of go to what I've bucketed as the last era that I'm talking about. I'm going to call it the modern era, and I'm starting it at 2015 to the present. The reason I chose that period of time is that's when IE drops back under 50%. And that to me is a really interesting time to think about, because all of a sudden that means, guess what? Browsers are competitive again. As soon as the browsers become competitive, something really interesting starts to happen. It's like the browsers realize, oh, I don't think any one of us is going to completely take over and win again. Let's actually start caring about standards. And what happens is, as the browsers actually start collaborating on standards, all of a sudden browser innovation just really takes off. And in the last few years, I would say that browser innovation has absolutely exploded. If you go over at MDN and try to just like read about all the things that are built into all of the browsers, you're going to guarantee see things that are like really cool that you've never even heard of or thought about. It's just like kind of ridiculous. I would say, at least for this developer, browser innovation is now outpacing my ability to keep up with it, which I think is interesting. And we kind of have an embarrassment of riches, I would say. You know, we have things like web components and custom HTML elements that have been in the browser well supported for years and years, but it's just now starting to like become mainstream. We have things like WebSockets that have been there for a while to do bidirectional communication. JavaScript has become more and more mature. The modules have made like code management so much better. And we have things like import maps that are going to make it possible for us to eliminate build tools in a lot of cases. And then we have whole new things like WebAssembly that are starting to get more and more supported. That's eventually going to let us choose whatever language we want. But I would say in the developer community, and of course I'm generalizing grossly, I realize that. For the most part, though, I would say we're mostly still coding like it's about 2015. We're mostly choosing frameworks that tend to reinvent rather than leverage web standards in a lot of cases. And a lot of times we're still like transpiling our code to obsolete, in a lot of cases, versions of JavaScript, still dealing with complex builds. And you're seeing this like oscillation in the development community to like, let's render everything on the client, and single page apps are the way to do it. Oops, that wasn't so good. Let's render everything on the server again. And it just seems to be like swinging back and forth, which is, it's just interesting to me. So let's kind of talk about some approaches that I've seen actually useful for dealing with all this stuff. And let's start with what I see as kind of the fundamental problem, which is managing state. And if we talk about managing state, we kind of see a design pattern for managing state keep emerging again and again. It's a functional design pattern. If you look at Redux or Elm, or on the server side in Elixir, you have Gen servers or LiveView. Because it's a design patterns like emerge over and over again. That's like kind of the definition of a design pattern. And it's interesting that this one keeps emerging as often as it does. And at its core, I don't think it has a good name. I've been referring to it as event state reducers, but the basic idea of the design pattern is really, really simple. It's basically functions, reducer functions, and those functions typically take two arguments, an event that happened and the current state. And then they return a new state. And the way the system manages state is anytime something happens, an event is emitted, it gets passed to a reducer function that then gets the current state and that event and gets a chance to return a new state. And it's a loop. And that's kind of how it keeps track of state. And just to kind of see how this looks like kind of a little more concretely, let's think about we're building a to-do list application, and we're going to create some event state reducers to manage the state of our to-do list. So at the beginning, we start with an event to add an item to a to-do list, and it looks like this. And it gets handed to a to-do reducer function. The first argument is that event. We just give our event a name and an item. And then the second argument is the current state, which is when we start our app, the current state is just an empty list, nothing. Okay, and that function, not surprisingly, it returns a new state, which is a single element in that list. Blah, blah, blah. Somebody adds another item, and we just call that same to-do reducer again with another item. And the second argument now is the state from before. And then we return a new state with this 2 items in it. So very simple example, but hopefully gives you a feel for like what this pattern actually looks like. Okay. So there's some things about this pattern that are really kind of nice. I think it's pretty easy to understand. It's very predictable. These are just pure functions, so they're really easy to test. And they're also really well suited to asynchronous because there's no shared mutable state. And that works out really well in practice. So let's talk about another simple idea that's caught on and been pretty useful in simplifying application development, and that is the idea of dumb components. I kind of saw these first show up in Ember.js, but I've seen them a lot of places since then. React, obviously, a big one. Angular, but honestly, you could look at any of the frameworks, and they're probably going to have the idea of components. And when I say dumb components, what I'm really saying is components are dumb if they only essentially do 2 things. They render data, they like render their state, basically. Often that comes in as props. And they dispatch events if something happened. So if they're dumb components, that's it. That's all they're allowed to do. Render state, send out events. That's it. So let's take an example of what this looks like to make it a little bit more concrete. And we're going to look at a comment section. And a comment section, I'm going to do it as a custom HTML element. And it's like a comment section that you would like, if you had a static website, you just want to drop a comment section on the bottom, you can plop this HTML element onto your page. That's the idea we're going for. And this is what the code for it looks like. This is a comment section custom HTML element. If you haven't seen custom elements before, I'll walk through this. Hopefully it's pretty easy to follow. I'm using a library called lit, which just gives me some syntactic sugar for building custom elements, makes my life a little easier. And that sugar kind of starts at the top with that custom element decorator. That just basically declaratively says the tag name for this guy is comments-section. And then the class implements the element. And the way it works is I'm defining a state, which is called comments, and it's just a list of strings. And then I have a render function whose job is to render that state. And lit is going to take care of anytime my state changes, re-render. So it does that for me. And rendering those comments, I'm just like outputting an unordered list of the comments. And I have a form where you can enter a new comment. And that form, when it's submitted, calls add comment. And add comment is just dispatching a custom event called add-comment with the payload of the comment. So it's rendering state, it's dispatching an event. Pretty much that's it. And it clears itself just so like the form's a little easier to deal with. All right. So that's fine. That's a simple dumb component, but like by itself, it doesn't really do anything, right? Because like where do the comments actually go? They just like the event fires and nothing happens. Like that's no good. That's not an app. So what do we actually want to do to actually be able to send them to a server? So at this point, we'd say like, oh, well, we could make an API and maybe we want to do REST. Maybe we want to do GraphQL. And I'm basically here to say like, hey, is there a simpler way to actually handle this? And what I really want to introduce is the idea of like, let's take these 2 design patterns and put them together. So this is what this ends up looking like. We have our client that's dumb components. They render state, they send events, and they subscribe to state changes that can be pushed down. So that's a new thing. On the server, we have those same reducer functions that we saw earlier. They are receiving events pushed up from the clients. they are running the reducer functions to make the new state, and then they are pushing those state changes back down that the client is then subscribing to. And in order to implement this pattern, I'm going to show you several different implementations. The first one I'm going to show you is called live state. It is not the first or only implementation of this pattern. It consists of a client-side JavaScript library and a server-side Elixir library. Elixir is a language that makes it really, really easy, and it suits this pattern very well, and I'm going to talk about why in just a minute. But let's actually go through the example. So if we go back to our comments section custom element, I'm just going to add a couple things to it. I'm going to add a couple more decorators. The first one I'm going to add is that live state decorator. And that's basically just establishing a WebSocket connection to the backend. And I'm telling it the URL to connect to. And the topic is just like the thing that I'm interested in. I'm just saying all the comments. And then I also have a list of events that I want this element to be able to send. And essentially that event send thing says, hey, if you see a custom event add-comment get fired, push it up over the connection. That's what that says. And then the other decorator that's new there is that live state property, and that just basically says this property of the element is managed by live state. So that's it. On our backend, this is what our backend code looks like. So this is Elixir. If you haven't seen Elixir, I'm not going to do a whole Elixir tutorial, but I'm going to try to at least explain this code enough that it makes sense. It's a module which implements a thing called live state channel, which is my library itself. And then the two functions to make this application go essentially just set up the state initially and then actually implement the state reducer. So that init function is just returning a structure that's like a map with a field of comments whose value is an empty list, and that's the initial state. That's it. And then in that handle event gets invoked anytime that add comment event fires, and it gets the comment as a payload. It gets the existing comments as the current state, and it's returning a new state with that comment added. So that's it. That's the entirety of the code for the comment section. It's not doing anything as far as persistence. Obviously, in a real application, it would, but I'm keeping simple so we can focus on the pattern. So actually seeing this guy in action, this is what it actually looks like to use this element on an HTML page. I have a single script tag to bring in the element definition. I have my pretend silly website, and then I have a comment section at the bottom. And all that together looks like this. On the back end, let me bump that font a little bit. Is that a little more readable? Yeah, it's not too bad. Another comment. Hello, stir track. And it works for adding a comment section to a website. So, pretty basic example. Thank you. Woohoo, comments. All right. So let's take this apart just a little bit. How does this actually work under the covers? Well, you saw the comment section element, but that live state decorator is doing some work for us, obviously. It's making a WebSocket bidirectional connection to our backend in the connect callback when that element's added to the DOM. And then it's also wiring up an add-comment event listener to push events over that WebSocket connection. It's also setting up a subscription so that state update messages that are pushed down over the WebSocket connection, it knows that in that state there's going to be a comments property that refers to my comments property on the element, and I'm going to set that value based on what's in the new state. And then lid itself is what's taking care of re-rendering on state changes. So that's how it fits together. You might have some questions, and so I thought I'd address some of the hopefully obvious ones. So I guess one thing worth pointing out, our state now is all on the server. And that state is conversational. So like anytime there's a new user on our web server, guess what? We have a new little tiny state instance on the back end to hold that state. So something needs to hold state for every single connected client that's using our application. And obviously, like that could be millions of connections, right? Millions of stateful connections. And your first thought might be, that's crazy, it'll never work. But I have kind of a secret up my sleeve, and that secret sauce is Elixir, and really the thing that Elixir's built on top of is something called Erlang. Erlang is not as popular maybe as other technologies, but it's quite old and quite mature, and there's been like 25 years of people working on like highly concurrent distributed applications. And they've built a whole platform around how to do it. And one of the things that came out of all these learnings is a process model that is unlike other process models. If you say process, immediately you probably think like operating system processes. Or if you're a Java guy, you might think of something like threads. The way that Erlang does processes is an order of magnitude smaller than either of those things. And because of the choices that they've made, those processes are so small that they actually can stand up to the load of that kind of an application and do it efficiently. With the technology that I'm using to build this stuff, things like Phoenix channels, which is a thin abstraction over WebSockets, they've done a lot of work to provably say that yes, you can actually scale to millions of stateful connections on just a single server. And it actually does work and keep running. So it's one of those things where you first see it and you're like, that can't possibly work. But the Erlang Elixir guys have kind of proven this out and made it work. And we're doing practical application development this way, and yes, it actually does work in production. So what do we like about this pattern? What do I like, I guess is really more accurate. But I like the state lives in a single place again, the server. It's not shared, it's immutable. And really the thing that I like, I guess, the most is that it lets me operate at a higher level of abstraction. I'm not dealing with requests and responses, I'm dealing with events and state, which are more intrinsic to the application. We get another side benefit though, and that is soft real-time applications are essentially free, and that is because events don't just have to happen as a result of the user doing something. They could really come from anywhere. And it doesn't matter where the event comes from, running that reducer function, computing the new state, and pushing it down works exactly the same way. So let's take a look at what happens when we want to try to make our comments real time, as in like somebody adds a comment, all the other users see it right away. Let's do real-time comments. In order to do that, what we need to do, and this is it, we need to add pub/sub to our backend code. And that's what it looks like to do this. There's just a couple more things going on. We're using a built-in pub/sub library that's built into Phoenix. When a user first connects, we subscribe to the pub/sub channel called comments. When a comment gets added, we broadcast the comment over that channel. And then we have one more function to handle the case where a comment is coming from a different user. And that's in that handle message, which is doing exactly the same thing. It's just returning a new state with a comment on there. And all that together, if we go back to our app, oops, I hit the wrong button. Let's go reload this guy. We have 2 tabs. And if I go hi from this tab, I see already it's over here. Hello again. And everything just works. It's all updating in real time. Sorry. There we go. It's just updating in real time, and we've made no changes to that front-end code at all. That front-end code is just doing exactly the same thing. So that's pretty cool. Let's talk about some variations. I said at the beginning this was a design pattern talk. Let's talk about some other implementations of the same pattern. Sorry, my voice is giving out. So the first variation we're going to talk about is live view. I'm just curious, have people heard of Phoenix Live View? It's maybe a little niche, just a few people. So really properly, live state's the variation and live view's kind of the original. And live view kind of came up with this idea. And the difference between live view and what I showed you is live view is Elixir front to back. So views are rendered in Elixir, events are pushed up over WebSockets, and state is pushed back down. And with live view, there is JavaScript involved, as you would expect, but it's entirely like encapsulated in a library. You don't actually have to write any JavaScript as part of building a live view app. And this is kind of what it looks like. The same example of comments, this is the same thing in live view. This is what the template looks like. The comment in this case is just like a little bit more complex, and it has an author and text. But other than that, it's exactly the same. We're looping over the comments and displaying them, and then this phx-submit, the client-side library knows to find that thing, and it knows how to then send an add comment event for you. So you just don't have to write that JavaScript yourself. On the back end code looks almost identical to what I showed you with live state. You have, instead of an init, you have an amount function that creates the initial state, and the handle event does almost exactly the same thing. And the net result looks almost exactly the same. Hello. And you can add a comment. So that's kind of the first variation. How am I doing on time? Not too bad. So let's talk about the second variation. And that is something called live templates. Live templates is kind of taking this idea from live state and saying like, hey, could we make building an app as simple as just editing an HTML file? What if we didn't even have to create a component at all? And the way it works is there's a custom element called live-template that connects a client-side template to a server-side channel. It renders state by re-rendering that template. It takes care of like letting you declaratively say what events to send up, and it's using a client-side template library to do that evaluation. That client-side library is called Spray. It's not super well known, but it is really kind of nifty. And all put together, what it lets you do is get started to build an app with only just an HTML file on the back end. And this is what it looks like. How's that as far as size? That's not great, is it? That's a little better. Is that readable? Okay, cool. So this is live template. We have our live template element, and that is where we're establishing the connection to the backend. We have a URL attribute and a topic that looks like the same as the decorator we saw earlier. And inside of that, we're using a template element. And that template element, if you were at a talk earlier, they talked about it there, but it's just basically a template element. If you haven't used it, it's just inert markup by itself. Inside of that template element, we're seeing some extra funky looking attributes like each and text and send submit, and those things are provided by Spray. And I think they're fairly straightforward, but we have an unordered list, and that each is just looping over our comments, and that text basically says, put the comment inside of the element. Our form, this send submit is basically saying the submit event for this form, when that happens, I want you to send add-comment as an event to the back end. And live template is able to do the conversion between the form event and the custom event payload. It just like knows how to do that by looking and seeing what are all the values, and in this case, there's only one. So all that together, all that together It just works exactly the same as before. It's just that we didn't have to write a whole element to do that. We could just like start adding HTML to our page and go. Oh, okay. Pretty good on time. So an interesting aside, and this is like nothing to do with the pattern that I'm talking about, but I thought it was really cool as I built this out. You'll notice that I'm not using a build tool at all for live template. And if you haven't seen them yet, I'm using something called import maps to make that work. And import maps are really, really great. They let your browser resolve and fetch dependencies for you. So if you look at that example, I didn't kind of talk about it, but let's talk about it now. I am not using any kind of client-side build tool. I have this script tag, and then I have what's called an import map. And that import map is just mapping that bare import onto a URL to fetch that script. And there's a tool called esm.sh, which is transitively taking care of getting my dependencies for me so that everything just kind of works. And yeah, I found that to be like a really interesting and productive way to start building things. So yeah, import maps are really great. And there are a couple of really useful tools, esm.sh and jspm.io. If you're interested in learning more about import maps and starting to incorporate them into your process, those two tools in particular are really great at building your import maps for you. Okay, end of that aside. Let's talk about signals. How many people have heard of signals? Okay, quite a few. Good. So signals are a pretty recent thing, but they're really interesting in that they're like an emerging standard across pretty much all of the major frameworks for being able to handle reactivity. And they kind of describe themselves as reactive primitives for managing application state. And at their core is they're just things that track access to them and trigger renders anytime they change. Like I said, they're being adopted pretty well across the major frameworks. Solid.js, Preact, Angular, I know all support them well. React, there's a couple libraries that add them in. They tend to, for whatever reason, be last for adopting some things sometimes. But the other really interesting thing about signals is they are now making their way through the TC39 standards process, which if it goes all the way through, that means signals are going to be actually baked into your browser for you. They'll just be there. You won't need an external library at all. And so I thought it was interesting to try to like incorporate signals into this pattern. So I built another small thing called live signals, which basically just lets you add a signal and then connect it to a backend. And so it kind of lets us do the same thing that we've seen already in the other two examples. Live signals so far is just supporting Preact and the TC39 version, but adding support for another backend would be really, I think, pretty trivial. And let's see what they look like in practice. So this is the same example that we saw earlier, but now we're going to do it in Preact. Preact, I'll say up front, I'm a Preact noob. I barely know what I'm doing, but it was pretty easy to build out this example. And in this case, after my imports, this is what it looks like to create a signal that's a connection to that same backend that we saw before. I'm using a create Preact signal function from the library, and that signal, or that function, sorry, returns two things. It returns the signal itself and a dispatch event function so that I can send those events back up. The connection information looks pretty much the same. And then from there, wait for that guy to get out of the way. Oh man, I'm sorry. In the comments component, I'm setting up an input handler and a click event, and then I'm really just like rendering the comments list again. And those events, really the interesting one is on click. That's where it actually hooks up to dispatch event to push that custom event up over the channel. And all that together. Oops. Oh yeah. Looks like that. Hey, this is Preact. And it works the same. And just to kind of show you, like, all of the examples are just connecting to that same back-end channel. At least they should be. If I haven't messed something up. Yeah. So let's actually start with blank slates for both of them so I can prove this works. Hey, really, it works. And if I bounce over to Preact, it should be there. I think they're in inverted order because I did something silly. Order matters. Sure enough. Yeah, so they really are different implementations connecting to that same backend channel. I just kind of wanted to demonstrate that. All right, so there are a lot of other implementations of this pattern out there at this point. And I thought I'd just kind of give shout outs to a few of them. LiveView.js is basically a clone of LiveView in JavaScript on the front end and the back end. I don't know really what kind of traction and adoption it has. I'm more familiar with the adoption story for LiveView, which is quite large at this point. On the Ruby on Rails side, they've done a thing called Hotwire, which is in a lot of ways kind of like an attempt to learn from the ideas in LiveView and implement them in Ruby on Rails. And it's fairly mature at this point. It's seeing a lot of traction and adoption over on the Ruby on Rails community. And then in PHP, which is a community I'm admittedly less familiar with, there's something called Livewire and Laravel, which at least seems to bill itself as like bringing over some of the ideas of LiveView over there. But there's a whole lot more out there. There's a link I can't click on because I don't have internet that's kind of like a list of all the different LiveView things, implementations, but that will be there for you in my slides. We've talked a lot about ideas, but I think it's worth kind of saying like, some of these ideas might seem new, but we've been using at least LiveView in production for a good few years now. And it really has made a huge impact in terms of like how we're building apps. Like I said, you know, we kind of got to a point where by default, we were building a client app and a server app and keeping everything in sync. Since we've moved to LiveView, it really has been the experience of like, we're back to just building a single app. And what that means is we're really actually able to go twice as fast. And especially as like a custom development shop, that's really been a huge impact to us. You know, there are places maybe where that matters less than others, but if you're in the space where like you're spending clients' money, you know, it really matters a lot. And it's been a big deal for us. And it's also been a lot of fun. In general, like the developer experience has been pretty favorably received as we made this transition. So Live State, that's newer, but it is starting to catch on. We've used it on client projects. I know of at least one startup in Spain that's using it to build a customer support app. So it's starting to take off. It's particularly well suited if you're building like embedded applications. So if you want to build an application that's designed to drop onto somebody else's website, regardless of where it serves, Live State is a particularly good solution to that problem. Some production examples to kind of look over. Launch Elements is an example of a kind of product that we're building using Live State. Cars.com, I would say, is the largest that I know of implementation of live view in the wild. They've been working on that for a couple of years now, and as you might guess, they get a ton of traffic, and they've done lots of talks. You could probably Google and find a lot of talks from the Cars.com folks about their experience with live view and what they've been able to do. So so there's a few different things to choose from here as far as like, okay, I want to implement this pattern. And so which implementation do I want to go with? I would say if you are willing or able to go all in on Elixir, I definitely can't recommend LiveView highly enough. But that can be a big stretch. And I would say if you're not ready or able to go all in on Elixir, Live State, like I said, is particularly strong for embedded apps. Live templates is really, really easy to get started with. And then if you do have a JavaScript framework where you really want to stick with that, I think live signals and signals in general are going to be a pretty good option for like doing reactivity across frameworks. So I definitely have some time for questions. I think that's kind of like the main meat of my talk, but I would be happy to field some questions if there are any. Thank you.
How does LiveView work if the connection's interrupted?
Great question. How does LiveView work if the connection is interrupted? So it is actually monitoring the connection all the time, and it will display like a banner warning that, hey, the connection has been temporarily interrupted, and then just resynchronize state as soon as it comes back. But it does require a connection to actually really be able to do anything useful, but it does handle an interruption quite gracefully.
How well does it work with apps that have spotty, like connection is spotty? We're talking about a place where I don't have very good connection. Does my app still perform well? So that I disconnected a bunch.
Yeah, I would say LiveView is probably not going to be great in like a semi-connected environment. That's an interesting question, though. And the question is like, how does this handle like essentially no connectivity or very spotty connectivity? I would say LiveView probably would not be a really good option in that environment. Something like Live State, you could persist the state to local storage pretty easily. You'd then have to like, send all that back up when things came back online. Is that the guy you meant? Okay, cool. Yeah, you. Sorry.
How does this differ from using SignalR?
I am not as familiar with SignalR and how it works on the back end, so I'm probably not able to say.
To me, what you described seems very similar. You basically connect to a hub on the server side, and then you have two-way communication. Like I said, if something happens, you got two people connected directly. SignalR will send, if people subscribe to that event, and they'll get it updated from their view.
Yeah, I might add a slide for SignalR and try to do some comparison, but I am not a .NET guy, so I haven't done much SignalR, but I don't know like what does are there reducer functions? How does that look? What does that look like? But that's absolutely something worth looking at. Yes.
So have you had any success on any like mobile development, like React Native or anything like that?
I think React Native would work really well. I do have like a React hook that would basically, the same thing I did with Preact and Signals. There's a React hook that would do almost the same thing. That should work just fine with React Native. I haven't done that myself. What we're typically doing when we do mobile apps is kind of like implementing the whole UI in HTML and CSS rather than React Native. But that's worked well. Like we've wrapped LiveView apps into mobile apps, put them in the App Store, and are using them in production, and that absolutely works.
Question about like session affinity. Like, do the requests get sticky on a particular
That's sort of handled so transparently with Phoenix and Elixir that I just haven't had to worry about that. So I would have to dig into that to really answer that question. I guess the thing I can say positively, graceful enough that I don't know the answer because it just works, if that helps.
How many nodes do you run in your backend? Typically.
So I'm thinking with production, I think we probably have at least we're using Azure, and I'm probably guessing it has a couple nodes, but Elixir scales really well, and the amount of time you actually need like a whole cluster is really not that often, surprisingly.
Where do you find you draw the line between state that stays on the client and state that goes to the server, like checkbox?
I try to do as much as I can in terms of in server-side state, but yeah, if there's something where there's no reason to send it up at all, I might just keep that as like state in like, for example, in the example I'm showing, like if I had a more complex comments component, maybe there's some piece of that state that essentially I just don't wire up to live state at all, and it's purely on the client side. There's been a few cases where I've done that. But in general, like for application state, I'm usually trying to keep that on the server. Oh, nope.
So what's been your experience with dealing with concurrency issues or race conditions? Is that any different than other patterns where you have state on both sides?
Yeah. How are you dealing with, and I'm sorry, I should keep repeating these questions. How are you dealing with concurrency and race conditions? So in the example, the pattern that I'm showing, the way it works, the example, like every connection is essentially getting their own state. So there's no actual race conditions to deal with in that scenario. The only potential would be like, what if events got out of order? And in that case, I didn't go much into the details of live state, so actually thanks for this question. Something else worth pointing out that I really should have it. Live state is able to like efficiently send down changes as JSON patches. So by default, it's going to diff your state and just send down what changed. And if that message gets out of order, there's a version number that's tracked that'll go like, oh, I got a change for a version of state that's the wrong one. I'm going to go request the whole state again, and then it'll just get it. So it's going to deal with those kind of race conditions, but the race conditions with like users sharing state, that's not a thing because that's not what I'm doing. If I need to share anything, it's just over PubSub.
Sorry, one more.
Go.
Come back one more.
Yeah.
What do you recommend for a backend? Do you use like Redis or Mongo or like a combination?
So Elixir itself is really pretty good at just managing state effectively and persistently, and also it's extremely resilient. It's super great at like handling crashes, and like that's kind of like built into the platform. So honestly, you might not need anything. If I do, I tend to like just like save it to Postgres if I have long-term persistence. Like it's honestly like fairly old school and conventional for most of my apps. All right. Well, thanks very much.